So glad that you were able to join us today or coming online, and we appreciate the tremendous interest in this very, very important issue. We've got some wonderful speakers from academia as well as from government entities, and we selected them based on the information, first of all, to help provide scientific based and up to date information on this particular issue. As you look at social media, if you look at just the media in general, you see all sorts of things going out there as far as information. Some is accurate, some is not. And I hope by the end of the day, we'll help clarify some of those points and that you'll have a better idea of exactly what the issue is, what scientifically, what this fly is all about, then also what we can do as the public or ranchers or wildlife enthusiasts to uh, help address this issue, and then also to get a better understanding of the different government agencies that are involved in this issue that are right now they're doing a lot of work in trying to address this issue both in Mexico, other places, as well as in the United States. And so we feel like we have a really good group of people. So I'm going to go ahead and get started. The role of Texas A&M AgriLife Extension Service is to help provide education, and that's what we're going to do today. And we have two speakers that we'll start off with. They are from within Texas A&M and Texas A&M AgriLife Extension Service. They're both from our entomology departments. We'll hear now from Sonia Swigert, who has a PhD in entomology. She is our extension specialist that works for many years in this particular area. She received a PhD at the University of Florida, and she works specifically in these biting insects, disease vector insects that impact cattle and other livestock and humans. She does a lot of work in vector-borne insects. Also joining her from the Department of Entomology is the department head, and that is Philip Kaufman. Dr. Kaufman does research in this area. In fact, he did research in this area for 15 years at the University of Florida. And we are so fortunate to have him on our faculty because he worked through this issue in Florida when it was found in the Keys of Florida back in the 2016 to 2018 period. In fact, if you Google his name, Philip Kaufman, and you look back and put in University of Florida, you'll find videos and articles that he did back then. So we're fortunate that he really is kind of the tip of the spear for us because he understands the issue. He understands how it was responded to in Florida and other places around the world. And also, I think, has a very good handle as to what is going on here in Mexico as it progresses, as this issue progresses. All right, so with that, I'm going to turn it over to Dr. Swigert and then Dr. Kaufman and let them take it away. Thank you.
All right. Thank you so much. I appreciate that introduction, Dr. Hale. So we'll begin by talking about the New World screwworm itself as a fly and information regarding the different stages and the impact it can have. First off, the New World screwworm is recognized as Cochleomya homnivorax. That is the name that's given to it. And this is a fly that the larvae are found to infest into the living tissue of live animals. They do have a preference for what we consider a warm-bodied animal, such as livestock and wildlife more so than anything else, but they can also be found infesting into pets, animals, humans, and birds on rare occasions. And this infestation of the larva into these animals is referred to as a form of myiasis. The name homnivorax came about because of the fact that they did find that they would infest into man, and that term actually means man-eater, although again, we usually see them more frequently in livestock. And the damage can be very detrimental. It does cause serious injury, and an animal left untreated can actually die from these infestations. Over the years, they've had identified that they do have a preference to be found in tropical forests and wooded areas, but they will seek out their hosts in pastures where animals are located or in fields if those are available. And they've also found that they happen to be found in clusters. So they're not evenly distributed in an area. So if you're having to do some type of surveillance for them, you have to check many areas because, again, they will be distributed unevenly throughout those areas. The historical range for this fly was all the way up into southern part of Canada and all throughout North America, south from there into Central America and into South America, consuming most of the continent of South America. But they generally prefer to be in areas where the temperature ranges from 64 to 91 degrees Fahrenheit, with peak activity occurring around 86 degrees Fahrenheit. They have found that they generally do not respond well and have little to no activity when the temperature falls below 59 degrees Fahrenheit. So that's one thing that we have going for them is that they do not do well in cold temps. They are known to range further north during the summers, but they will fall back, obviously, in the winter time. And they do better if they're in an area with heavy rainfall. So that is one thing that goes for them. But that doesn't mean that you have to have heavy rainfall for them to be in an area. They are a daytime active species with little to no activity at night, and they do not do very well under windy conditions. There are actually two species that we refer to as screwworms, and you can see their pictures on the screen at this time. But they are a little different from each other. So the one we're really worried about right now is what we call Cochleomya homnivorax, the New World screwworm. But the other one, which is in the picture on the right, is called the secondary screwworm, and it's Cochleomya macellaria. Both of these are blowfly species that are fairly large in size in comparison to a normal housefly. They'll be a little bit bigger. They are a metallic blue-green color with orange eyes. I would like to point out, though, with these two pictures that there are some differences that you will see in those appearances because the picture on the left is actually a dead specimen. So when these flies do die, they do lose some coloration, and that can vary that appearance from blue to green and things of that sort. Another thing to note is that they have three stripes that go down the back or the thorax of them. And that's another area that we can use for distinction between the two species. Both species do have those three stripes, but the center stripe for the Cochleomya homnivorax does not reach all the way to the head, so that middle stripe. One other difference between them that was recognized and has been known is that the secondary screwworm only infests dead animals. So the homnivorax will come in and infest a live animal, but the Cochleomya macellaria will only show up if that animal has passed and is now a carcass, and that's when they actually will infest those animals. I'm going to talk a little bit about the life cycle now, and this is just a brief outline here. So roughly the life cycle from egg to adult will take about 4 weeks if you put it all together, with the larval stage or the immature stage being about 2 weeks of that time period, and the pupa and adult stage being another part of that, which takes up another couple of weeks of that life stage. The screwworm eggs are laid by the female directly into or on a wound that they find on an animal, but they can also use exposed mucous membranes to also lay those eggs on. They need an area that's, has a little bit of moisture and is a direct opening for their larva to get into that animal. Those eggs will be laid in groups of about 200 to 300 at a time. And they will start to they will hatch out within 10 to 12 hours, and those little larvae that come out of those little eggs will start to feed on that tissue and cause severe damage. And you can have multiple flies come in and lay their eggs on those wounds. So you'll end up with more than just a couple hundred flies. You'll end up with thousands and thousands of eggs because those other flies will come and lay their eggs there too. The larva stage, as pictured here on the top, is tapered on one end and has very distinct mouth hooks that they use for feeding. These larvae will then start consuming on that live flesh, and that's a major distinction again for this species as opposed to other blowfly species that we have in the United States, and that these ones only feed on that living flesh. They'll start to grow in size after they hatch and get much larger. And as they get bigger, they consume a larger amount of food at the same time. And they get that screwworm name because of the fact that they have this odd screw-like appearance, being that their body segments are covered in little spines and they actually feed with their heads down, which is their mouth hooks. And they basically burrow into the tissue, kind of like a screw being pushed into wood, so screwed into wood. So that's where that name came about. They'll stay in that tissue until they're fully consumed enough food to allow them to pupate and move into that next life stage. And again, if they're left in there and not treated and removed from that animal, they can actually kill that animal within a week if the infestation is severe enough. And a lot of times that's because that infestation will be in an area that gets to the vital organs of the animal more than that they've eaten enough of that animal. But a lot of times those infestations are in the head, so it can be a direct route into the brain, or they're in the stomach, which can also be a direct route into some vital organs. They can't share these hosts, these larvae with another animal, though. So we do know that there'll be more adult females that will be coming and be attracted and lay their eggs. They do give off a distinct odor, though. So that is kind of one of the things that goes with it. You can kind of tell that they're there because of a smell. And that smell also attracts in more females to come in and lay more eggs. Once they're done feeding, again, within that 5 to 7 days, they will remove themselves from the host and go into the ground and pupate. That stage, again, can last about 5 to 7 days on its own. And then, of course, from there, they will hatch back out into a new adults, and start that cycle all over again. They are again found mostly in warm-blooded animals. They're rarely found to infect birds, and rarely infect humans, but that's not impossible. It's just kind of on the rarer side. We generally see them in livestock and wildlife. One of our biggest concerns is going to be the movement part of the screwworms. Now, the flies themselves can travel, obviously, since they do have wings, a decent distance on their own, but not extensive distances. So they're known to go about 10 to 20 kilometers, which is about 6 to 12 miles, to find a suitable host. But if there's hosts closer by, they obviously won't expend the energy to go and find hosts further away. They'll go with whatever they find first. But the bigger concern is really the movement of infested livestock or wildlife, which can spread these in a much further distance. And of course, this can be up to hundreds of miles at times if there's no inspections occurring. So now I want to kind of take us through the history of screwworms, because this isn't a species that is new to North America or any of the Americas, but it has been gone for a little while, and a lot of people are not really familiar with it. So it was first recognized as being present in the southwestern part of the United States in 1842, so quite a few years back. It received its name in 1858, when it was finally named as Cochleomia hamnivorax, and at this time it was also recognized to be found in the French Guiana. In the 1930s, there was a change in its location, which it had originated in, originally been identified in the southwestern part of the U.S., but there was a severe drought in Texas and some other areas where cattle were kept, and they had to be moved to the southeast in order to allow for them to finish out the growing process. But in that process, it also took the flies with them. So then we saw an expansion of this fly into the southeastern half of the United States as well. In that time period, they also realized that there were actually the two different species. Up until 1933, they thought they were dealing with a single species of fly that was coming and infesting these animals. But then they realized that there were the two species, the one that came in when they were living, and then the one that showed up after those animals had died and succumbed to their wounds. In the mid to late 30s, they started to do a lot of research on this fly because they realized the impact it was having, and it was time to do something to control it. So they started looking at some mass production techniques so that they could better suit themselves to manage it. We needed to learn how to grow it into large numbers in order to figure out how to control it, which sounds a little weird, but that's kind of how the process goes when dealing with insects. They also came up with the concept of the sterile insect technique, which will be explained a little further after my presentation by Dr. Kaufman. In 1937, they did more studies because, again, we wanted to understand this fly. We realized that if an animal dies before the fly larvae are able to survive for within a 24-hour period, then the fly will die. So those really small larvae, the very first instar and second instar stages, if their host dies before they're able to get far along in development, then they will die as well. They also is when they realized that they had cold intolerance, so to speak. They couldn't really do well in those cool temperatures. So those were all good things to know so that we could better prepare ourselves in controlling them. In the 50s, they started to do work with ionizing gamma radiation to look at ways to actually sterilize these insects so that we could look for proper ways of managing. There is a slight delay there from the 30s to the 50s, and that was due to World War II that did take the scientists away temporarily until they could come back to the problem. In 1954, they started to do this eradication attempt in at Sanibel Island off of the coast of Southwest Florida, and we're about 80% successful, which of course we want 100% success rate. So that was good, but not great. And one of the main reasons was it was so close to the mainland that the flies were migrating back over from the mainland onto this island. So then they decided to go somewhere else. So they went to the Caracoa and found out and did the studies there and were able to achieve 100% eradication, which was all, again, good things because now we actually had a process that was going to help get rid of this fly. So next step was to actually start to get rid of the fly. So they had to start production and releasing of the sterile flies in the United States to start removing it from the US. And they began over in the southeast, basically eradicating the entire portion up to the Mississippi River. And that took about 4 years, and they were able to achieve that eradication. Once they achieved it in the southeast, they moved over into past the Mississippi into the southwestern portion. And that's where that program started to expand to the Mexico border. And they set up some barrier zones and some treatment options, which was about 400 males, females released per square mile per week. And this started to work. So they started to achieve eradication in Texas and New Mexico and some of the other southwestern states. But there were some setbacks. So you'll see that some of that comes back. So even though the efforts were working and they were getting good results, they were having some issues dealing with, nature. And that's kind of how that happens. So by 1966, they had expanded that barrier zone to about 200, 300 miles, and they had really started to achieve eradication from the United States. This was doing really well as again, and then they started to have a few more setbacks because we needed to expand it further. So they needed to start moving into Mexico so that we could get better results, because when we'd have mild winters in the United States, those populations would recede back over from Mexico. So in 1967, we had finally gotten numbers down pretty low, less than 1,000, which was 99% reduction. But a few years later, due to numbers staying high in Mexico and again mild winters, there was a severe outbreak in Texas and some of our close states that was up to 96,000 cases, and that caused them to have to start producing a large number of flies to get that back under control. In the late 1970s, they started to develop other methods to assist with the sterile male techniques, one of which was a SWAS adult lure, which is used for trapping. So it's just another tool to add to what we were already doing, in addition to opening another production plant in Mexico to help with this elimination of this fly. And this, again, made it better so that it was better achieving the eradication in the United States as well as starting to work through Mexico. But there was a setback in the late 80s in which there were some introductions into Florida on dogs that were being brought to the United States, which is something that happens every once in a while. And in those situations, they actually did have to do some releases to help remove those populations in the Florida cities in which those dogs were entering. So programs started moving into Central America to, again, further eradicate this fly from the United States. By 1991, Mexico had been eradicated, and again, they started to establish more plants further into Central America. The development of COPEG, which is the organization that still currently helps run this program, was developed, and they set up a permanent biological barrier, which is at the Darien Gap in Panama. And they finally were able to successfully eradicate the fly from the entire western half of Panama all the way up into Mexico. So we now had the US, Mexico, Central America, and Panama, the western half of the Darien Gap, completely successfully eradicated. And that leads us to the most recent years. And in 2016, there was a slight setback where there was an outbreak in the Florida Keys amongst the key deer that had to be tended to. And Dr. Kaufman will talk further about that. And then it gets us to where we are right now. So 2023 is where we believe the current outbreak had begun. With the Mexico reported cases happening in November 2024, and last being listed as expanding up into the Veracruz in 2025, which has now led to the U.S. border being closed to cattle and livestock production or movement.
Thank you, Dr. Swiger. We are going to talk a bit about management of the screwworm issue should it arrive in the U.S. And it's important to understand that we have a long history with this insect. We've known about it for well over 100 years. This is a little different than many of the other organisms that we deal with as introduced pests, but it is still an introduced pest. But we do have many successful examples of how we have previously eradicated it and tools that we have available to us, as well as pending tools that are still being developed. So I want to start with the concept of integrated pest management. We use this throughout agricultural entomology, plant pathology, weed science. It's how we manage our pest issues. And it involves using multiple techniques to reduce a population. Many of you have heard of sterile insect technique, and it is certainly critical to solving this issue, but it is not the only thing that's important with solving the screwworm issue that we're being presented with. The other aspect of IPM, and really why it developed, was because of the resistance development to by many of our pests to many of the insecticides that we've used. And so these interlink into a pest management program. This case is a little different in that we're really talking about eradication. Integrated pest management drops the pest population to where it's not really a problem for the commodity that we're trying to protect. But in this case, eradication is the goal. Right? Part of this involves every one of you out there, and it involves reporting. It is absolutely paramount for this program to work successfully that we have individuals who are able and willing to report instances where they have encountered the screwworm. And this is something because if people don't report it, the fly is going to successfully develop. It's going to produce many, many offspring, and it becomes that much more challenging for us to solve the issue. Regarding this, when we see screwworm show up in an area, there are some steps that are taken. One is that we conduct surveillance for the adults. Right? You try and trap adults. They can be attracted to traps. These are not things that a rancher or a homeowner will necessarily use themselves. These are programs that are run by APHIS and other groups. Mexico has its own group for surveillance as well. They use products such as swarm lure, which is an advanced version of the SWAS lure that Dr. Swiger had mentioned. In some cases, we can use rotting liver. It produces some of the same volatile chemicals that attract the flies to it. And it's a little bit more available, but it does attract a wider variety of the blowflies that we may not want to see. We do that so that we identify where those adults are. And when we know that there's populations of adults in an area, then we can take advanced steps toward perhaps releasing sterile males in an area and be more effective at the use of that limited resource. It also involves monitoring for larvae. This means animal examinations. And when I talk animals, it's everything from humans and dogs and cats all the way through livestock and wildlife. We are dealing with a fly that really prefers to lay on mammals and mammals that have wounds, and mammals particularly that aren't examined all that often are the prime area for its development. When we find this insect in an area, it is going to trigger things such as inspections or limits on animal movements. And that's a good thing. That's how we prevent this fly from moving great distances. And it's absolutely critical that people understand their role in this. This was very important in containing the fly problem when it was in the Florida Keys some 10 years ago. All right, pre-treatment of hosts. We're going to hear some folks discuss that a little later, but understand that pre-treatment of hosts comes with great risk and great challenges, as well as the lack of approved products that we don't really have at our disposal at this point. So protective measures are really not on the table at this point. And lastly, the sterile insect technique. And again, sterile insect technique is not a standalone process. It is a component of this overall pest management program. So you'll see it represented here as SIT for sterile insect technique, and I'll explain how that works and why it works with this particular pest and not every pest. And I have a YouTube link up here that you can copy down the address, and this is posted later. It'll probably be more appropriate. It is an overview of how the program works with our COPEG partners in Panama. All right, the sterile insect technique. So the flies are produced currently at one plant in Panama, although there are other plants that are being discussed to come online to help with this production issue. The normal production for this plant is 20 million sterile flies per week. They have cranked up production to over 100 million flies per week due to the outbreak and the seriousness of this outbreak. Understand that only half of these produced insects are males. It's a 50-50 sex ratio. The insects are mass produced on an artificial diet. It's a very highly controlled environment. It is done on an industrial scale. The image on the top here shows the individuals rearing the flies, placing tens of thousands of maggots into a tray that will subsequently pupate. Once they turn into these pupae, which is the bottom right picture on the screen, they are exposed to a short dose of cobalt-19 where they receive their irradiation treatment. The reason that this works is that radiation exposure creates multiple breaks in the chromosomes of the flies. And the sex chromosomes, the sex cells, the sperm and the egg, are single-stranded, so they actually break much easier than a double-stranded normal DNA strand. And so the flies become sterile, they're unable to reproduce, but they are still alive and they're still functional, and that's absolutely critical for this process to work. The pupae are then taken out and released into areas with known fly populations. There's a couple of ways that that works, and I'll share that with you here in a moment. All right, there's some basic principles as to why SIT works and why it works with this particular insect, and it doesn't work with every insect that we have. One is that the female will only mate once in her life, and so if she mates with a sterile male, then she essentially becomes irrelevant to producing offspring, and that's absolutely critical. We're going to drive that interaction through the mass release of these sterile males. The fly itself is pretty rare in nature, especially compared to other insects. And you'll hear some numbers on that later in this presentation. The fly can be mass reared, right? They use non-animals for the rearing, and so it can be produced in large numbers. As I said, 100 million flies per week. It can be sterilized without changing the behavior. If we sterilize these males and release them, but the females don't want to mate with them, then it's a failed program. And again, the flies are released in mass numbers on a regular basis. It can be ground-based, like the picture on the right at the bottom. Those are some dispersal stations that were set up, and that allows you to, when you know that there are flies in an area, to overwhelm the wild male population so that you all but guarantee those females mate with a sterile male. They use aerial dispersal when we have a more widespread and what we call endemic population, a population that's widespread. Then you have to disperse your flies a little more across that landscape. Right? Those females are still going to lay eggs, but those eggs will never hatch. And it essentially takes her out of the reproductive line. give you a couple of examples before we move to the next speaker. So this was an incident that happened in Panama about 16 years ago. They had in the center of the circle you see is about the area where the Panama Canal is. On the right-hand side is the Darien Gap area, which is the biological quarantine or barrier zone where there was limited livestock production, and it was the area chosen to maintain this quarantine line. But occasionally incursions happen in Western Panama, which you see here within the circle. And so in April of 2009, there was a number of cases that were identified. They started the control program in mid-May when they had everything lined up. They released sterile insects as well as doing other parts of the IPM program. They released the sterile insects for 12 weeks, and that involved 60 flights, and it released 250 million flies. And they ended that program in late August. So it took about 3 or 4 months for them to contain that outbreak in that small area. To give you an idea, and again, this is numbers from 16 years ago, it cost about $1.1 million to contain a very small outbreak in that area of Panama. And they really were quite close to the plant, so they didn't have a lot of the transportation costs incurred as well. With respect to the 2016 New World Screwworm key deer outbreak, we're going to have some folks talk a little bit more about this later, but to give you an idea of the effort that went into this. So the screwworm was identified initially it's thought in June. The report was not made as properly as it should have been. And so the fly went undetected for an additional couple of months. And when it happened on one Florida key called Big Pine Key, and there's a small population of key deer on that island that are endangered. When the bucks started shedding velvet and entering rut and fighting with each other, the fly population took off, and then it became noticed because these deer many of the deer on the island are very friendly, and people started noticing these horrific injuries to these animals. In the course of this eradication, which again was on an island with a single bridge leading on and off the island, they had many deployments, and 350 individuals were involved in this. They released 188 million sterile flies across 35 release sites. A lot of this was done with ground releases, but there was aerial applications. They had set up medication treatment sites for these deer. They're a non-hunted population, so it wasn't nearly as much of a challenge to get a registration for this or a use of this. And they had applied the medication to at-risk deer populations. Right? It took until early 2017 for the eradication to be completed and declared over. And in total, it was about 8 months worth of effort from the time they started controlling it until they declared it re-eradicated. And although they tried some genetic testing to determine where those flies originated, they were unable to with the tools that they had at that time. And my last slide before we move to the next speaker is showing you an overall timeline. So what's presented here is about 70 years worth of effort. Started on the island of Curacao, where we had the first sustained eradication. And as Dr. Swiger mentioned, we moved from the southeast to the southwest Texas. I identified a few islands in the Caribbean that were in the U.S. territories and eradicated those islands. We then joined with Mexico and worked with the Mexican government and the ranchers and populace of Mexico to resolve that issue. And look, it took 20 years for us to essentially eradicate it from Mexico, then joined with our partners in Central America and eventually moved that eradication line down to the Panama Canal. And so it is going to be a bit of an effort for us to push this back. You'll hear later in this presentation where we currently stand. And I will reiterate that we do not have New World Screwworm in Texas at this point, but we are more than happy to work with anyone who has any questions. And with that, we will move to our next presenter. So Dr. Tom Haregrove is going to discuss prevention and treatment strategies and why New World screwworm is a threat to livestock. Dr. Haregrove is a professor and extension specialist in the Department of Animal Sciences at Texas A&M University, where he received his bachelor's, Doctor of Veterinary Medicine, and his PhD at Texas A&M. Dr. Haregrove has practiced veterinary medicine for many years with an emphasis on cattle. He is a diplomat with the American Board of Veterinary Practitioners and is certified in beef cattle practice. Dr. Haregrove.
Okay, thank you very much. So my challenge or what I'm asked to do here is go back to producers. What can we do to kind of prepare for this? And so I guess my first thing I'm going to start out is be vigilant. In other words, pay attention to what's happening around you, but don't panic. And I've received call after call after call from veterinarians, producers, county extension agents, about what are we going to do? The sky's falling or whatever. Well, again, I think it's very important that we take this serious, but again, not to panic. If you expect a screwworm infestation, you think you've got a potentially even having screwworms, and if you've experienced a lot of other issues like, okay, a sudden loss of calves, wildlife, etc., contact your veterinarian immediately. Okay, so again, I can't emphasize that enough to work with your local veterinarian. Now, let's say that you find something and it's Saturday afternoon and your veterinarian's off to a meeting or whatever, but at any rate, there's not anybody. So you say, well, I'll talk to him Monday. But Monday you're busy and then you get around to it Wednesday. So don't delay. In other words, if you cannot reach your veterinarian or if you don't have a veterinarian, we're going to talk a little bit about the importance of that too. Contact the Animal Health Commission and there's a 24-hour hotline. And so you can call that anytime, 24 hours. And I've used it in the past and they certainly will return your call and give you the advice you need. Okay, so I think one of the most important things we can think about here is right now is biosecurity, right? So again, like I said, I don't think, it's not a deal to panic. This is something that we've just got to start paying attention to. So do you have a veterinarian? And it's amazing to me because I talk to people all over the state pretty often. The producer will call and finally, we'll go to visit and we'll have you talk to your veterinarian. Well, I don't have a veterinarian. Okay. If you don't have a veterinarian, get a veterinarian to help you with this biosecurity. In other words, biosecurity, you've got to build that program to what your risks are. So there's no such thing as just a canned program. So build a relationship get a veterinarian and build a good relationship with him. Again, build a relationship with your county agent. I know for years, county agents, everybody knew where the county agent's office was, and every county knew the county agent. I go to counties sometimes now, and sometimes even counties that you wouldn't expect. And, well, could you tell me where the county agent's office at or whatever? And they have no idea what's a county extension agent. So again, I think building that relationship with that agent, and then first thing you want to do is sit down and analyze your risk and then develop a plan of action. So what kind of risk do you have for the screwworm? And again, you've got some valuable information so far to kind of help put some of that stuff together, but you just have to come back with what are your risks? And again, surveillance is so important. Be vigilant, stay alert, and report any abnormal or suspicious events. For example, if you see maybe more deer that are dying or whatever, then that's maybe should raise a suspicion, right? And again, build a relationship with your neighbors. What's happening what's happening over with your neighbors. So kind of all come together on this. Monitor for ticks and other external parasites. Now, why is this so important? Spinous ear tick and the Gulf Coast tick particularly really caused a lot of issues in this 1970s outbreak. And what they do is that those ticks, they damage a lot of tissue and it gives the screwworm a place to set up. So that's the reason you had a lot of screwworms. And I think there was a picture on the ear or something, in one of the presentations. But monitor for ticks, treat for ticks, right? And we get calls all the time. Well, I have ticks. Well, what are they? Well, I don't have any. Well, send me some ticks so we can identify them, because that's very important. And as Dr. Teal says, ticks are moving. So again, they're part of the problem. And then what type of operation do you have? Is it a cow-calf stock or seed stock? In which do you have a lot of cattle moving in? Maybe a stocker operator is going to be a lot of turnover. All those things are going to make a big difference in what your biosecurity plan is. Is it open or closed herd? Do you raise your replacements? Are you buying replacements? Where are they coming from? The other thing is monitor the wildlife population, hunting and recreational activities on your operation. Right? So again, somebody might be coming in, or I'm going to come in, I'm going to bird watch, or I'm going to come in and fish in a pond or something, and then they bring their pet. So again, those are all important things to monitor. And then livestock guard dogs, again, you still want to be, checking them pretty often for any lesions, anything like that. Observe your own animals after castration or other surgical procedures until they're healed. And again, I think the other thing is equipment. Keep your squeeze chute in good shape. We see a lot of injuries just because a squeeze chute there's some damage to it. It's kind of worn out, maybe. Good welder, a little bit of time can fix a lot of those things, but we see a lot of like cuts, especially getting the foot caught in something, or other places, or even in the alleys coming up fences and stuff, holding pins. Those are real important things to look at. The other thing is real concern with a biosecurity plan is things have changed so much since the 70s when we had it the last time. So we have a lot of smaller producers now. There's a lot of countries been sold off in smaller units. So a person might not have a big place, but a little place, and maybe he's got a handful of cows on it, right? So again, we really need to get the message out to those people, how important it is to also understand this condition and be on the alert for it. The other thing, Dr. Gill and I have talked about this a lot. A lot of people now are using a lot of day workers, stuff like that. They don't have the facilities, or maybe have the facilities, but are getting along in age or something like that. So anyway, if you're using, day workers coming in, they come in, they castrate your calves, et cetera, et cetera, et cetera. Maybe it's a good idea to have them come back and maybe ride through those cattle, just checking, make sure that everything's healing up and there's no problem there, especially if there's any, concern about threat to the screwworm. Okay, so if there's anything else I can really push is how important it is to develop that biosecurity plan and be vigilant. Just be vigilant. Looking. Anything that you see that's out of the ordinary, then you need to report it.
Thank you, Dr. Haregrove. We appreciate that. Our next presentations presentation Wildlife Perspective Impact on Native Species are presented by two individuals, Terry Hensley and Sarah Wyckoff. So Dr. Hensley received his DVM. Dr. Hensley is served as the Assistant Agency Director for Diagnostic Services since 2012 at our Texas Veterinary Medical Diagnostic Lab. In his role, he is charged with overseeing veterinary services, intra-agency collaborations, case coordination, and consultations with TVMDL's clients. He also serves as the liaison between TVMDL and the multiple regional, state, and federal partner organizations to oversee this agency's regulatory testing components. Prior to joining TVMDL, he served as the Assistant Agency Director for the Texas Animal Health Commission. Dr. Wyckoff works for the Texas Parks and Wildlife as a wildlife veterinarian, where she is one of two wildlife veterinarians. She joined Texas Parks and Wildlife in 2022 after working with wildlife in places such as Massachusetts, Florida, and Arizona. She received her bachelor's degree in Arizona from Arizona State University and her DVM from Midwestern University. And thank you both for joining us and providing insight for the wildlife aspect of this challenge.
You've already been told that it affects all warm-blooded mammals. And when we come to wildlife, we have many more reports of white-tailed deer being affected. It's not the only wildlife species that's affected, but it seems that they really experience the brunt of an infection when it comes to New World screwworm. But when you look at Texas nowadays compared to what it was back in the 40s, 50s, 60s even, we have a lot more other types of hoof stock in the state in the form of exotic animals. And these exotic hoof stock from Africa and different places, they're also going to be susceptible to the screwworm as well as our native white-tailed deer and mule deer. And I think it was mentioned earlier that birds, while the reports are infrequent, birds are susceptible to New World screwworm. So we need to be paying attention to them. Even though we know in the past the infection has not been reported very frequently in these animals. So looking at white-tailed deer, historically the reports, as I said, showed a higher rate of attack in white-tailed deer than it did in some of the other smaller type species of animals. Some of those reasons may be the buck shed their antlers, so you are left with a raw pedicle there that is very attractive to New World screwworm. And once they get started, there's a lot of vital organs fairly close to that pedicle, so it can be devastating to that deer. Bucks fight during the rut, so they experience, scrapes, punctures, so forth, that again can be attacked by the New World screwworm. And it's already been pointed out, the wound does not have to be very substantial. It can be as small as a tick bite. And many white-tailed deer in certain areas of the state carry a fairly high tick burden, so you're going to have ample spots there for a fly to lay eggs if they exist. The other thing that was devastating in white-tailed deer was on fawns. And on these newborn fawns, that unhealed umbilical stump, the belly button on that deer is attractive to New World screwworms, and it can be very devastating if you've got a high fly population during the fawning season. Again, some reports show as high as 40 to 80% fawn mortality, so you can lose almost the whole cohort of new fawns if you've got a high fly population during that fawning season. Again, deer seem to be hit harder than other wildlife species. There are reports that in areas where we had high fly populations, you can lose up to 50% or more of the deer population. And that's talking adults, not just the fawns, that's the whole population. So we had many areas, white-tailed deer were not very prevalent. That wasn't just in Texas, that was even through other southern states. And part of that was due to New World screwworm. Now, there are other things that played a part of that too, but when we eradicated New World screwworm, the deer population started to recover or to increase. And now there's over 5 million deer in the state of Texas. Now, again, it wasn't just due to New World screwworm eradication. We also had improved wildlife management techniques. Deer management was improving. We paid more attention to habitat management, and we had scientific advances in just natural resource management in general. So other things were important, but we need to remember that New World screwworm was one of the main factors holding down deer populations in the state. And if we look economically, deer hunting in Texas accounts for around $4.3 billion to this state. So that's also an important thing to look at when we talk about New World screwworm in wildlife. Now, Dr. Kaufman mentioned briefly the key deer in Florida. It's an endangered species of subspecies of white-tailed deer called the key deer, and that's the only place they exist on a number of the Florida keys. So in 2016, New World screwworm was detected in the Florida Keys. I don't think they still know exactly how it got there, but it did get there. And the problem is with white-tailed deer, with the key deer, they're a very small population of around 1,000 animals. And U.S. Fish and Wildlife Service estimates they lost at least 135 deer out of that population. So you can see they lost well over 10% of the population due to New World screwworm, and it was mostly in the males. And the reason for that was it occurred during the rutting season. So as males are fighting, again, as I said, they're experiencing punctures, scrapes, scratches, perfect sites for the female fly to attack and lay her eggs. It may have been a lucky thing that it was during the rut rather than during the fawning season, or it would probably have had a much higher impact on the key deer population than on males, because they lost primarily males out of that population. But they were able to control that outbreak by several ways. The sterile fly releases, of course, were extremely important in controlling that. But these deer, and many of the keys, they're habituated to the people there. They love these deer. So they were able to actually treat some of these, because the deer would actually take bait or treats from people. So they had that advantage. They also implemented some preventative strategies. As you can see on this picture here, feeding some of the medications, parasiticides, but again, has already been mentioned, that's not available to the rest of it. That was a special situation on a very limited population of animals and a very controlled site. But I think we can learn things from looking at what it did in wildlife to the key deer and what needed to be done to try to get that under control. It also pointed out that disposing of carcasses are going to have to be done in a particular way, so you don't continue to get some larvae that are near their in the final stages of development that can fall out of the wound and still develop. So several things can be taken from the key deer. And I think the next slide is Dr. Wyckoff.
Thank you, Dr. Hensley. Okay, so as Dr. Hensley and others have mentioned, white-tailed deer has been pretty susceptible to New World screwworm. However, we do have to kind of ask ourselves, is that because this is a larger animal that is more seen more, and also it takes a lot more infestation to cause a mortality event in that animal? So there have been reports of other wildlife species that have been affected by New World screwworm outside of white-tailed deer. So in southwestern Texas, jackrabbits and cottontails, opossums, those were all found to have confirmed New World screwworm cases, especially with the jackrabbits and cottontails, where they found that the normal botfly that will inhabit these rabbits actually sets up a perfect little wound for New World screwworm to go in there and cause infestations in these animals. Unconfirmed sightings from that area also included badgers, raccoons, coyotes, even armadillos, and of course some various cat and fox species as well. So this is just a reminder that although a big focus of wildlife is going to be white-tailed deer because of how susceptible the adults and the fawns are, there are other smaller animals that do move around. They can get into places very easily. Think about raccoons that crawl into feed, or rabbits that come in and onto the pastures. We do have to remember that some of these smaller wildlife mammals can also have screwworm in them. And also another thing that we have to consider is some of these exotics or non-native species. Dr. Hensley mentioned hoofstock. Feral hogs are another animal where their behavior, based on some research out of South America, shows that they could be less susceptible to severe infestations compared to other animals, meaning that they have the ability to kind of have these New World screwworms on them, but because they wallow and because they get dirty and muddy, it might not cause these large, severe lesions compared to other animals, which can allow them to carry them further because they're not going to get sick as fast from it. One of the challenges in wildlife, too, is that we have limited label therapeutics for many diseases, but definitely New World screwworm in wildlife. And we have concerns about extra label drug use and meat withhold considerations. A lot of these species that could be affected are game animals, and so we do have to take drug residue seriously. Also, there are indications of therapeutic resistance or resistance to medications, essentially, coming out of South America, where ivermectins or ivermectins or other type of medications have been used long-term for screwworm, and unfortunately, resistance is building to those pharmaceuticals. And we also have to remember the diversity of New World screwworm susceptible hosts and host biology. Again, we're focusing a lot on white-tailed deer here, but we have to remember that any mammal can be affected, and rarely birds as well. There's also impaired seasonal surveillance that we have to consider. And also just overall, the wildlife audience may not be as disease-minded as the livestock industry. And so it might have to play a little bit of a catch up when it comes to reporting disease, understanding surveillance, and getting all together to kind of understand this disease and do what we can to prevent it in wildlife.
New World screwworm poses a serious threat to wildlife if it re-enters Texas and the other states here in the U.S. We can't observe wildlife to the same degree that we can observe livestock because we can't put our hands on them, predator. And free-ranging wildlife. So again, one of the reasons it posed such a threat to the wildlife species. Some may be affected more than others. Dr. Wyckoff's correct. We see white-tailed deer easier. We can observe them easier because they're larger than some of these smaller species that exist here. There's other things. Some of them are nocturnal. We already heard these flies don't move around at night. So maybe there's other reasons that we see certain species affected more than others, but we have to pay attention to all of them. And the biggest message I think I want to leave everyone with is this is going to be a problem for all Texans, and we all need to take heed and be involved in it. And it doesn't matter whether you're a landowner, an outdoor enthusiast, you're a hunter, you're a hiker, bird watcher, bike rider, wildlife manager. It doesn't really matter. It's a problem for all of us. And we all have to be involved, and we all need to be vigilant. And we need to participate in surveillance efforts for this pest, as has been mentioned.
This is a team effort between all agencies, Texas Parks and Wildlife, the Texas Animal Health Commission, USDA, the Human Health Department as well. And we are all collaborating and working together. And, whether we get a report in wildlife or domestic or livestock, we are all communicating with each other and letting each other know what we're finding. Also, we would much rather submit to all types of false negatives than miss one that's really important and could be a potential screwworm. So please don't hesitate to reach out to your local wildlife biologist if you do see something of concern in wildlife. If you go to the TPWD website, you can find the biology through your county. There's a nice list there. You can go through, see who you can contact, and then report any concerns that you have there.
We're going to move on to our next presentation, which is the public health perspective. It's going to be, the presentation will be delivered by Leanne Lawton. So Leanne is the state public health entomologist with the Texas Department of State Health Services Education. She received her bachelor's degree from our department here, the Department of Entomology at Texas A&M University. And she later completed her Master of Science from Stephen F. Austin State University. She served as a research scientist at Louisiana State University and has been in private practice for 10 years. Leanne?
So human cases are being reported alongside with animal cases from countries where New World screwworm was previously controlled. People can be affected similarly to animals, though the number of cases for humans is only a fraction of those reported in animals. So this is an animal disease for the most part. So we'll talk about the risk factors when in areas of concern with primary screwworm presence. We'll talk about signs and symptoms of an infestation and might involve a healthcare provider to remove larvae. Ways to prevent an infestation if you do find yourself in an area with New World screwworm. And excuse me, information for animal owners and veterinarians at the end. So there's a slide at the end with a bunch of resources and links from CDC, USDA, and others that are being continuously updated. For all the topics. TSHS is working on one as well. Infestation risk factors. So the primary screwworm, here you go, primary screwworm or New World screwworm, Cochlearia hominivorax, as we've come to know, is endemic in the American tropics and subtropics, including South America, Cuba, Haiti, and the Dominican Republic. And now they're back in Central America and southern Mexico. People at higher risk of exposure are those who travel to areas where these flies are present, those living in rural areas in those areas, or near livestock raised in these regions, or that work directly with the livestock themselves. Anyone with open sores or wounds from a scratch, surgery, cut, or even an insect bite or a tick bite, as we learned with the bot flies, that was really cool. Those people would be at higher risk as the flies will lay eggs near the open sores, any size. Vulnerable populations, including people who are immunocompromised, those either later in life or little babies, so the extreme ages. People who are weak or not mobile may be at higher risk, but seemingly healthy people can also host these flies. They will use mucous membranes, as we learned from Dr. Spiger as well. They just need a little mucus, like your nose, your mouth, and then they just reach that food source. So be aware if you do sleep outside in an area where primary screwworm is present, or if you're in the show Yellowstone. Identifying an infestation. So how to spot an infestation, signs and symptoms. Primary screwworm infestations have been reported as very painful. Never had it, sorry, I can't attest to it, but I've heard it's very painful, it's very sore. Your sores are going to get worse over time, not seem like they're not going to heal very well. They smell bad. They have bloody discharge. You might see some egg masses next to the wound, by the wound, and they're going to look like just these creamy white array of stacked shingles. Larvae might be hard to see in the early stages because they're very tiny, but after a few days, you might be able to see them. But because they live on live flesh, primary screwworm larvae will burrow down into the wounds, unlike other species of flies that can cause myiasis. These other flies will be feeding on the dead tissue, so they might be up top, closer to the surface. The larvae that might be observed or felt in open wounds. When you do see this is a little gory photo. Sorry about that for the warning or no warning. But this is where you're going to see them or feel them. So when you do find this or see this, please go to your primary healthcare provider. Let them know you're recently in an area where primary screwworm is present, and they can have a little look-see. So screwworm myiasis can quickly cause tissue damage and become debilitating or even fatal. And they can cause secondary bacterial infections, which is also very dangerous within those infested patients. So So prevention and treatment, prevention and quick removal are very, very important. They're key. Keep any wounds clean and covered as preventative measure. If you do feel wriggling or larvae in or around a wound, see your healthcare provider and tell them where you were, tell them what you think. Hopefully they won't immediately think it's delusional parasitosis. Show them your wound. And do not try to remove or dispose of these larvae by yourself. So there is a protocol, a certain way to dispose of these. CDC recently held a clinician outreach and communication activity call, or COCA call, late last year for healthcare providers. So they are aware, so people are aware in the event of possible screwmyiasis presentation. If you Google it, it's online. It's very informative. There is a proper way to dispose of larvae, and surgery may be needed if infestations are deep in sensitive tissue. So that is why we say go to your healthcare provider. But just in case you decide you want to dig into your own skin, kill all the larvae by placing them in 70% off ethyl or isopropyl alcohol. Do not just place them in a trash can. Do not throw them outside, out the window. I don't know if you're just picking at skin, something like that. There is a very important protocol. Kill them. Send any suspect specimens to the Texas Department of State Health Services. This is us here. You can send an email to the vet, that's the@dshs.texas.gov. And someone will walk you through the forms and alert the lab that a sample is on the way, and we'll give you all the directions and the addresses and such and such. Samples will be sent to CDC via us, DSHS, for diagnosis. And what's very cool about CDC is they will accept pictures for telediagnosis. So if you're not really sure, you don't really think it looks like it, the screwworm from all the photos that you're seeing, send a photo to CDC at their websites, and they might be able to help you out. You can contact us as well. We can have a little look-see, or there's entomologists around, but really don't wait. Just send it over to Texas Department of State Health Services with that email, and we can get it out quickly. Here's some more information for healthcare providers. And it may be accessed here. So cdc.gov, all of these great sites. This is where this information is all coming from. Some information for animal and owners and veterinarians. There we go. For pets, here's the good stuff, probably what you guys are waiting on. So the information for companion animals, owners, and veterinarians. If a pet is suspected of having New World screwworm because you travel to an area where it is present, contact a veterinarian or your veterinarian immediately, and they can help you remove those larvae. They're going to place it in alcohol again, and they're going to send it to the lab for ID. Any wildlife should be going to Texas, or contact Texas Department of Wildlife, and anything in livestock is Texas Animal Health Commission. So traveling with pets. Dogs entering the U.S. will need a dog import form. So there's a link available online. It is a CDC form. You can also find all of this, how to bring your pet back into the United States, on the USDA website. There is a link there. If your pet is coming from a country or region where screwworm is known to exist, it needs to have that certification from an official government veterinarian of the region that you are in. So this certification has to have these statements that say this dog or cat or animal has been inspected for screwworm within 5 days prior to shipment into the United States, and that this dog is free of screwworm, or that this dog had screwworm and is held in quarantine and now is free of screwworm. And this has to be prior to leaving that region. So for information obtaining that certificate endorsement by an official veterinarian, you can contact the animal health competent authority of the country where your pet is traveling from. And you can, if you need help looking for one of the vets, there is a list on the USDA website. But also you can contact World Organization for Animal Health, and they will help you out to find that. So there's no screwworm form that you'll find. It'll just be a certificate from this official vet and this CDC one of it. This is the dog import form that you'll find from that link on CDC. Excuse me. It's very short. You just fill it out. It has a rabies question, and you can add notes in there. All of these resources are available at these sites. You can Google them. CDC's got a lot of stuff. There is a site here, Mexico News Daily, that had cited the human cases if you were interested about that. There's the laboratory forms from DSHS. You can contact them. You can contact us at the vet at dshs.texas.gov. We can all help you out with that stuff. And there are the links to the forms. And that's all I got.
So our final presentation, so we have two presenters, Dr. T.R. Lansford and Dr. Louisa Collins. Dr. Lansford earned his DVM from Texas A&M University and has been involved in regulatory veterinary medicine most of his career. He most recently worked at the Department of State Health Services Meat Safety Assurance Section as the Assistant State Director. And he previously worked for Texas Animal Health Commission as both a region director and an assistant executive director. Dr. Collins it serves as the area veterinarian in charge for APHIS Veterinary Services in Texas, a post she has held since January of 2024. She joined APHIS back in 2009, working as an export certification veterinarian and then as an area epidemiological officer. Prior to working for USDA, Dr. Collins was in private practice in Austin as a veterinarian. Thank you both.
And also thank you very much for everybody who's tuned in today and for those that will be listening to this somewhere along the way as it's released. Certainly lots of good information here, lots of questions still out in there in the questions and answer piece, and certainly hope to try to address some of those that haven't been addressed as we move forward with this portion of the presentation. So moving along here, we wanted to talk about, why the big hubbub with New World screwworms and what are we worried about? Why are we so worried about this? And share some information on that. Talk about some of our efforts in response, some of the things that are going on in Mexico, et cetera, as Dr. Kaufman mentioned. But I think that it's important that everybody remember and take to heart that this is a community effort. This is a situation or an issue that impacts all of us, regardless of livestock ownership, wildlife ownership, management, et cetera, or just if you're got companion animals and need to be aware of these things as well. This is an issue that we've been watching since the early spring of last year as it started moving into in Costa Rica, and Costa Rica declared an emergency, and it started marching up through Central America. And so certainly have been working with USDA to keep abreast of this situation. And unfortunately, it's in southern Mexico and presents a pretty significant threat to the United States and Texas particularly. So why are we so worried about this? Well, I think it's important to think about some of the history, like has been presented already by some of the folks here, is what do we gain by being free of New World screwworms? Well, right now, because we're free of screwworms, we're realizing about $1 billion in direct benefit to livestock producers in the United States and about $3.7 billion to the overall economy of the United States. And that doesn't seem like necessarily big numbers, but when we start thinking about what it costs to have screwworms, and I've got some information on that here in just a minute, certainly those numbers are significant. There was some questions about where else it is in the world, and certainly the screwworm is considered to currently be endemic in Cuba, Haiti, the Dominican Republic, and South America. So hopefully that kind of answers some of that. I'm having some lag in my slide. There we go. Certainly, from the standpoint of a pest, this is a foreign animal pest, or considered a highly impactful foreign animal pest or disease. It is expensive and deadly. If you look back at some of the history back in the 30s when screwworms were endemic in Texas, Texas lost about 180,000 head of cattle alone in that year. And so certainly the livestock numbers were nothing like they are now. And so, percentage wise, we certainly stand to have some death loss and some things that could go along with an infestation of New World screwworms or reintroduction of New World screwworms. Other things to think about is, what are the potential costs if we were to have this pest back in the United States? And it's estimated to be about $540 million to livestock producers across the United States on an annual basis, and have an impact of, again, about $1.27 billion in the United States, and more specifically in Texas. Lindsay, I think I'll get you to advance the slides, please, if you go to the next slide. We're going to see some increased costs of production, and certainly the animal death piece of it is factored into that. But the other things that this pest can certainly create are issues related to productivity. And so obviously these infested wounds and or mucous membranes and these lesions that are created by this pest cause significant distress to the animal and damage to the animal. And that can certainly yield to chronic conditions that make the animal less marketable and certainly less productive in its lifespan. So it can also, from a companion animal standpoint, certainly create some conditions that become chronic conditions that animal has to deal with, and the owners of those animals have to deal with for the rest of its life. So other production costs that will be increased will be increased veterinary costs and certainly the medications that go with treating these infestations. As time goes on, and hopefully we get more information about some of the potential preventative compounds that could be used, there will be some additional costs for the implementation of things like that as well. And certainly one of the things that producers need to be thinking about is, in terms of production costs, is the extra labor that it's going to take to do the increased inspections. As Dr. Haregrove mentioned already, the face of livestock production in this state has changed considerably from what it was in the 1930s, 40s, and 50s, where we have a lot more absentee owners that aren't able to necessarily inspect their livestock at the frequency that is going to be needed for if we have New World screwworms in the environment. And so certainly all of that extra cost and labor and the treatment costs that go with that are going to drive production costs up. Next slide, please. So just to kind of sum up some of the economic impact to what we're looking at here, this is an extrapolation of costs from 1976 outbreak in Texas and what it would be adjusted to in today's dollars, or 2024 dollars anyway. You can see on a per head basis that in the 1970s, the cost for cattle was about $82 a head, and that would equate to about $452 a head in today's dollars, or 2024 dollars. And certainly when you get down to the bottom and look at the overall losses, in 1976 compared to now, it'd be 132 million versus 732 million, and the overall impact on the economy now would be nearing 1.8 billion, or just exceeding 1.8 billion dollars. And these numbers don't include the impacts it would have on the multi-billion-dollar Texas hunting economy. And so certainly this is the big reasons why we're concerned about this pest, is not only from an animal welfare standpoint, but certainly from an economic standpoint. This pest will be one that will leave quite a mark on our economy. So next slide, please. Related to costs of eradication, and it's something that we've kind of talked about, the costs of production. And certainly, though, from a taxpayer standpoint, the cost of eradication is real. It will cost, and historically cost tens of millions, and now it's would be estimated it would cost into the billions of dollars to eradicate this pest if it gets back to the United States. Not to mention the one big cost is just the developing and expanding our sterile fly production capacity in the building of New World screwworm sterile fly plants that's come with a pretty hefty price tag of somewhere between $300 to $600 million, depending on where it is and what it is, and the resources that it takes to get those establishments built. And that doesn't include what it would cost to continue to operate one of those. Certainly, research dollars need to be spent to develop more effective treatments and other activities that we can use to help offset not only the infestations, but help prevent those infestations. And certainly from a response standpoint, it will require some cost in terms of getting out there and doing surveillance activities, to include doing inspections of livestock prior to movements and or any treatments prior to movement of those livestock around out of quarantined areas or infested areas. Certainly, we're already spending some money doing outreach, such as this webinar here, but preparing for these things and traveling to meet with producer groups and extension meetings and anywhere and everywhere that they'll let us talk about screwworms to increase awareness. We're doing that. We've been on that road now for several months, and I know that there are several other entities such as AgriLife and producer groups that are out there beating the bushes, so to speak, to increase awareness of this issue. Next slide, please. Next slide. So we talk about some of the clinical considerations. I know that some of this has been sort of talked about a little bit, but just to kind of bring home some of the things that you might see if you were dealing with an animal that had a potential New World screwworm infestation. These wounds may have a very small appearance at the surface, but can have some very deep pockets underneath the hide, so to speak, that may have hundreds of these maggots inside there. Has already been alluded to. One of the hallmark characteristics of these wounds or these lesions is the foul odor, and part of that is the production of pheromones by these larvae that attract the other female flies to come lay eggs. But certainly, as these wounds expand and you get necrosis of tissue around the outside edges and buildup of plasma and some decay in there, it will attract other flies as well that can and create secondary infections, which are actually more cause more of the fatalities in these animals than the actual damage usually caused by the screwworm maggot itself. And so, again, these may be small wounds, but they'll have deep infested pockets under the skin. A lot of times these animals will be depressed and off feed or separate from herds or self-isolate. Certainly something to think about. When you're thinking about looking at wildlife off in the distance, they may exhibit some things like head shaking, because a lot of times these New World screwworms will get into again on mucous membranes, not just wounds, but mucous membranes, and get into the ear canal and into the sinuses. And so you may see some animals exhibit some signs like head shaking out there in the environment. So, next slide, please. Morbidity and mortality. So, what is the effect and how deadly is it? And again, we've touched on a little bit of this, but this is pretty much an indiscriminate type of pest that will go after anything that's warm-blooded. It does have some predilection probably for livestock and wildlife species more so than birds, but certainly can be a pest associated with birds as well. As I mentioned, these animals can become systemically ill from secondary bacterial infections and sepsis caused by just those expanding wounds caused by these feeding maggots. In treatment with parasiticides can be successful when detected early. And again, early treatment is really important because not only does it get rid of the maggot in the environment and help with controlling that population of flies, but it also limits the amount of damage that occurs to the animal and also relieves that obvious discomfort and pain associated with these lesions. From a mortality standpoint, again, this really has an impact, as Dr. Hensley indicated, on neonates or freshly born animals. They have this pest has a real predilection for the umbilicus or the navel of newborns, and certainly can wreak havoc on the newborn population, whether it's wildlife or livestock. Next slide, please. Can we get the next slide? There we go. Perfect. So from a prevention and treatment standpoint, certainly if you have a suspicious case or suspected case of New World screwworm myiasis, contact your veterinarian immediately and help let them help you walk through what needs to happen with that case. in terms of treatments, any appropriate treatments to include parasiticides or larvicides, and any indications or needed treatments for secondary infections. From a standpoint of avoiding introduction of New World screwworms, as if they're in the environment, you want to do everything you can to prevent wounds in animals, and that's been discussed in terms of keeping your facilities up and trying to do everything you can to prevent the creation of wounds, especially when you're handling animals. If you notice wounds, cleaning and covering those wounds and preventing fly infestation on there is an important piece. If we have them here, certainly monitoring livestock and wildlife will be important, but also ensuring that we're not accidentally moving that pest around either through infested pets or vehicles where flies become entrapped and then get moved that way is something that we need to consider. And again, the need to report any suspicious cases immediately is really critical to our response efforts, and we'll touch on that a little bit more in just a second. Next slide, please. So in terms of treatments, what is approved right now? The only thing approved for use in the United States on New World screwworms and labeled for use on New World screwworms are these permethrin topical pesticides that can be applied to certainly the larvae in the environment. If you're cleaning a wound out and need to kill the larvae, these products will certainly do that, and they can also be used on the animal itself to help kill larvae. The trick to these as a topical is that these wounds can be deep and the maggots can be really far inside those wounds, and so it's important to make sure that those wounds are getting cleaned out very well and that this is being applied to make sure that anything that's left in there is getting killed. As Dr. Kaufman mentioned, and I know there's been a lot of discussion on systemic compounds that can be used as a larvicide, and it's important to remember that right now in the United States there are none currently approved and or labeled for use for screwworms in the United States. In the treatment of New World screwwormiasis, those compounds such as macrocyclic lactones or ivermectin, doramectin, some of that class of products can be used, but it's an extra label use and can only be used by a licensed veterinarian. That is one of the things that certainly from a response standpoint, we're pushing very hard with our partners at USDA and FDA to get a list of other products that can be used to treat and or maybe even prevent myiasis or infestations of screwworms. But at this point in time, there are no systemic compounds that are approved for use. Next slide, please. In the event that we get New World screwworms in the United States and in Texas specifically, there are some things that we need to consider from a management perspective that will help reduce or mitigate the impact of New World screwworms in our operations. And these things will include maybe changing some of our production practices, like the time of year where calving is done or other birthing periods are done. So that it's done in times of the year where the fly is less active, and certainly that will help decrease the impact of the fly or this pest on our newborns and our populations. But in addition, anything that we do as a production practice that may create an open wound would also need to be considered to potentially be changed at the time, or to be done at a time when the fly is less active, and or any time that we have New World screwworms in the environment, regardless of activity of the fly or not. Closer inspection, routine inspection, and monitoring of any of those types of operations where we create a wound would be highly indicated to make sure that an infestation hasn't occurred, and if there is one, that it can be promptly treated. So next slide, please. New World screwworm current status. I think it's really important that I reiterate and that we do not have New World screwworms in Texas at this time. They are in southern Mexico and have moved north into the states of Veracruz and Oaxaca. And certainly we're very concerned about that continued northern progression. And that's one reason why Of late, there has been more attention paid to the status of New World screwworms, and certainly from a production standpoint, with the reclosure or resuspension of the importation of cattle, bison, and equine from Mexico, there's been a lot more attention paid to this situation. But just as a background, there was a noted increase in cases of New World screwworm infestation in Panama starting in 2022. And then you can see that timeline up through 23 and on into April, May of 2025. I think it's important to understand that how fast this pest can move and how fast this infestation can spread, especially when you start factoring in things like livestock movements, which certainly was a big contributor to how fast it is spread up through Central America and into Mexico. Next slide, please. So one of the questions that we always get asked is, well, why this northern expansion? Why now? What's happened? And so there's been kind of a combination of things that have occurred that have led to the perfect storm, so to speak, for lack of a better descriptor. COVID certainly had an impact in terms of staffing at inspection points in Panama, and that was directly linked to a change in land use around the Darien Gap as well, where that area has been deforested and converted into grazing lands, which are highly sought after for finishing cattle in South America. So there was a number of unfortunate movements that occurred up through South America from infested animals moving from there into the Darien Gap area and then into Panama, and then on up into Central America for further processing. And in the meantime of that increased level of movement and unfortunately infested movement, it was also noted that there was a decreased efficacy of sterile flies, of the strain of sterile fly that was being used at the time. That has been rectified as of last summer. And certainly the strain that is being used now is being closely monitored to make sure it's maintaining its efficacy. But certainly that was a character or a compounding factor, if you will, in what the issue has been and why it's moved so far north so fast. So next slide, please. So what's the current status in Mexico? As of June the 2nd, there were reported 1,828 cases in animals, primarily livestock. There also has been alluded to 6 confirmed human cases in Mexico. The case that we're concerned or is most alarming is the case that's about 127 miles, and you can see the gray dot that's kind of by itself close to Oaxaca City, that is 127 miles past the established buffer zone that Mexico had put in at the Isthmus of Tehuantepec to try to hold the New World screwworm at that point. This is concerning not only because it's the closest to the United States, so it's about 600 miles, somewhere right in there, but it was found on a native animal, meaning that the animal was one that lived there, not had been recently moved in, which all of that equates to meaning that there's an established native or established fly population in that area since it was on a native animal. Also, we still don't have any surveillance information for what's going on in the wildlife populations in Mexico or Central America, so that remains as a kind of a great unknown there. Next slide, please. For those that are aware, as I mentioned, the borders were closed for the importation of Mexican cattle, bison, and equine on May the 11th, and the USDA has put some teams together, review teams together that are in the process. There's actually one in Mexico last week, I believe, and there's some others headed down to Mexico in the near future to evaluate what Mexico is doing in terms of their response, their surveillance activities, inspection activities, et cetera, for New World screwworm. And based on some of those reviews and reports that come out of that, we understand that there would be some potential negotiation for consideration of reopening the border. We don't know anything about how long that may take or what the factors are that may lead to reestablishing that movement of livestock across that border. So that's just kind of an update on where we are with that. Next slide, please. And so last, not last, but certainly getting close to the end is response activities related to eradication and prevention. We in Mexico, all of the fly capacity that's being produced by the sterile fly plant in Panama, which is the only one left right now, has been moved to Mexico, and they are continuing to work to establish a buffer zone north of the Isthmus of Tehuantepec to hold the fly at that point. They've established 2 dispersal centers in Mexico, but probably need to reevaluate that and maybe establish some further north so that they can better service the area of where the fly is now. We're kind of limited or behind the 8 ball on the number of flies. Really kind of need close to 200 million flies per week, according to the experts, to deal with the current outbreak situation in Mexico and Central America, and we're maxed out at the COPEG facility of about 110 million flies per week right now. One thing that's developed recently is on May 28th, the USDA announced that Mexico had agreed to convert a sterile fruit fly facility into production for sterile screwworms. Don't have a timeline on that, but that is being supported by funding from USDA. Next slide, please. Lots of preparedness efforts, obviously, related to this issue have been ongoing for a number of months now. USDA Veterinary Services has developed some strike teams that have been doing some training and setting up for rapid response should we have a case in the United States. And certainly the Western strike team has been headquartered at Moorfield in Texas. And more importantly, one of the big gaps was getting some additional sterile fly capacity, and they are working on that by establishing a sterile fly dispersal unit or facility at Moorfield and outside of Mission, Texas, and are also working on moving forward with establishing a sterile fly production facility there as well. Again, don't know exact timelines on that, but they are in the process of working through that. ARS, Ag Research, has certainly been working feverishly to assist with developing alternative treatment strategies and getting us working with FDA to get us some information on other compounds and that can be used to treat and or hopefully serve as preventatives on New World screwworms as well. Next slide, please. So Dr. Collins, our area veterinarian in charge with USDA, has got a few slides that she wanted to review.
Dr. Lansford and the other speakers gave everybody a really excellent overview, and I'm just glad to be able to be here and join them today to fill in a little bit more of what USDA's response has been and what we are working on currently. So as you heard, cases in Panama increased dramatically in 2022 and early 23, and APHIS's international services has involved heavily since that time in assisting those Central American countries with sterile fly dispersal and attempts to control this. Our overall hope is that we stop the fly currently at its location near the Tehuantepec Isthmus in Mexico, down there in Oaxaca. But we are taking steps like Dr. Lansford went over to prepare in case it does come closer. So as you heard, in November 2024, we were notified of the first cases in Mexico, and the border was closed at that time to imports of livestock from Mexico. And our trading staff worked really hard to develop a protocol for importing cattle at that time. But with the detection past the area into the state of Oaxaca, the border was closed again on the 11th. And as Dr. Lansford said, there's not a direct timeline for reopening that border. Teams are down in Mexico reviewing protocols and working cooperatively with them. And my understanding is that the border opening will be debated every 30 days or so. In May 27th, just last month, the Secretary of Agriculture did announce $21 million for that sterile fly production facility to be created from that existing fruit fly production facility in Matalpa, Mexico. That's right across the border from Belize. Currently, all the sterile flies that are being produced in Panama are being released around the areas in Mexico in attempts to stop the further northward expansion of the fly. Go ahead and advance the slide for me if you would, Lindsay. Thank you. Before I get to talking more about outreach, I'll just mention a little bit more about what we're doing to prepare should it arise here. And one of those things is creating these outreach documents. And I'm going to just point you to some APHIS websites because the information is changing very rapidly. It's being updated as we speak. And there are many groups working across different federal agencies to refine guidance should it reach our borders. As Dr. Lansford mentioned, we have had training for first responders. Those folks are positioned in Florida and all the Gulf states, including Texas. And they are train the trainers type people should we have to suddenly start trapping flies, doing surveillance should this get closer to us. We've had supplies ordered, and currently my staff has supplies on hand to collect and submit maggots. Texas Animal Health Commission has done the same thing. And we have also reached out to some of our partners in, for example, Food Safety and Inspection Service, Customs and Border Protection, and others that are involved in livestock and wildlife in making sure they know about this threat and are prepared to collect and submit samples if needed. And as you've heard almost every speaker say, reporting is super important. If this pest makes it to our borders, the sooner we find it, the sooner we can respond to it, and the sooner that we can hopefully eradicate it again. So advance the slide for me, please, Lindsay. So these resources are available online now. And like I said, they are continuously being updated. One way to find them is just go to Google and Google APHIS, APHIS. And on the home page, you'll find a landing page for New World Screwworm. If you click on that, you'll see a screen that looks like this with historical information. Some of the speakers gave you excellent presentations on that today, but more reading would be available here. The current situation in Central America and Mexico is also linked here. And then there are sections on what to look for, how to prevent it, and how it's treated, including some information about companion animals. And I'll mention one other section of the outreach that we've done here in Texas is we've provided lists of all the accredited veterinarians, and Texas Animal Health Commission has emailed them some outreach materials, and that appears to be working. My office has received since October 20 reports of suspected new worm screwworm in the state. The last 10 of those have been since May. So a dramatic increase in people seeing maggots, reporting it to us, and we take it seriously. Like other folks have said, we would rather find it's not screwworm and then risk overlooking it. So I'll state again, we have not found screwworm in the state of Texas. We have found some secondary screwworm, which is a normal finding. And but we have that capability to submit samples and get answers pretty quickly. So I'll just reiterate what other folks have said. If you suspect it, contact your veterinarian, your extension agent, the 1-800 number that was presented earlier for the veterinarian on call line, or my contact and information will be at the end of this presentation. Any of us can assist with handling those reports. Next slide, please. So this is one of our fact sheets that is currently available on our USDA website. It's available in English and Spanish. And if you want to grab the QR code, it's there. Next slide, please. And again, another brochure that can be downloaded. We are also ordering in my office copies of this actual brochure for distribution. Part of what my team does is reach out to different parts of sectors like feed stores, wherever they encounter veterinarians, producers. We're going to be spreading the word and using these brochures to do that. Next slide, please. And again, more resources all on our USDA website, more fact sheets, how to report, and some links there that'll take you to your state vet's office or my office, or if you're tuning in from another state, it'll have information there too. And specific guidance for veterinarians and other animal health officials, emergency response for producers, and again, the history and more info there. Next slide. So that's all I had to present for you today. I hope it was helpful. And I'll just leave you with this picture of the national, what they call the screwworm jar at the National Veterinary Services Laboratory. And just a word about finding this pest. Currently, this pest is not considered, it is not in the United States. It is a foreign animal disease at this time. So any suspected cases will eventually and pretty quickly be referred to the National Veterinary Services Lab. They are also equipped to look at photographs and give us a preliminary diagnosis, usually within hours. So again, if you suspect it, please notify. And the sooner we find it, if it gets here, the better chance we have of eliminating it more quickly than not. So with that, I'll turn it back over to Dr. Lansford. And again, thank you very much for having me.
Thank you, Dr. Collins. Just a couple other quick things wanted to go through and that maybe have related to more of the specific things that people on the call are interested in is, you know, from a response standpoint, what does it look like? And I think it's important that everybody understands that response is a three-legged stool that consists of treatment, surveillance, and movement controls. And without all of those, we can't successfully eradicate this pest again. And so in the United States, if we get a case or get this pest reintroduced and reestablished, until we get enough sterile flies to be able to deal with that situation, our treatment stool or leg is pretty short there. And so we're going to have to rely more on our surveillance and movement control pieces. And so in that light, we have developed a draft of a plan that we have shared with other states, working closely with kind of a multi-state group of animal health officials, state veterinarians, to try to get consensus so that we have some agreement about what that looks like. And certainly working with USDA, as because this is a foreign animal disease issue, they have a lot of input about what response needs to look like so that we can maintain business continuity. And so if you can change the next slide, please. Just wanted to touch on some more specific things related to this. And two of those legs, the quarantine and movement restriction piece, you know, we are at Animal Health Commission, and certainly speaking with other state animal health officials and USDA, very much so committed to the continuity of operations and making sure that while this pest, if it gets here and we have to deal with it, it is not going to impact the entire industry or across the nation, you know. And so because of that commitment, we're looking very hard at what do we need to do to be able to make sure that we're assuring our trading partners with other states and with USDA that if we're dealing with screwworms in an area, that we're doing everything we can to make sure that we're not allowing that movement of that pest or the further spread of that pest. And so quarantine areas will certainly have to be established, and we will require inspections and possible treatments prior to movement out of these areas. Again, we don't have the final draft of this to be able to share yet, because it's going through some clearance with USDA and making sure we're all on the same page there. But just overall, that's what it's going to look like. Is there will have to be some inspections and possible treatments to make sure we're not allowing for the spread of this pest. Surveillance is another critical piece. Certainly that will be important if we get this pest in Texas, because we're going to need to know where it is and what all is impacted, so that when we do get sterile flies, we're ready to go in having those areas identified where sterile flies need to be released, but also in an effort to help maybe gauge or better monitor our efficacy or impact that we're having with our movement controls. Certainly the wildlife piece is kind of a wild card and will play a big part of this movement of this pest in the United States. But anything and everything we can do as producers and responsible landowners and everybody in between to help mitigate and reduce the movement of this pest is going to be critical to our response and limiting the impact. Next slide, please. So again, this is just an example of some of the things the Animal Health Commission has put out, and all of that's available. These guidelines and et cetera are available on our Animal Health Commission website, and we've got that in the presentation at the end here. I certainly wanted to recognize that we're working very closely with our industry partners and our other state partners in developing response and communications to have consistent messaging that's going out, and certainly appreciate everyone that's on this call, your efforts to assist with that. As we work through these challenges and make sure that we're being consistent in providing updated information to everybody. Next slide, please. So reporting this, as Dr. Collins mentioned, at this point, this is still a foreign animal disease or just foreign animal pest. And it is reportable. Suspect cases are reportable and need to be reported to Animal Health Commission or USDA so we can submit those samples. And part of that sample submission, because it's a foreign animal disease, includes getting a foreign animal disease investigation, a number assigned to it. So it needs anybody who's got a suspicious case, whether it's a veterinarian or as an ag extension agent that's helping a producer or a producer themselves that contacts us, or sees a suspicious case. We certainly want to work through that process, get that number, and assist with getting the sample collected and shipped off. As Dr. Collins mentioned, the number of these samples that we're submitting has gone up in recent times. I've seen 2 emails during this call about suspicious cases today. So certainly people are aware and doing good surveillance out there. And we would much rather have false negatives and, or let me rephrase that, false positives in identify cases that truly aren't screwworms, rather than miss one that truly is a screwworm and get behind the curve on response. Next slide, please. This is included in a set so that if you're out and you notice that something suspicious and you don't have access or can't get to a veterinarian or contact somebody to assist with the sampling, this is just some simple things that you may have laying around that can help you collect a sample of screwworm larvae or fly larvae. Let me just put it that way, a fly larvae for submission for identification. So that's in our fact sheets as well on the web page, and certainly again, we encourage any sampling and contacting us so that early reporting and identification is accomplished so we can respond to this as quickly as possible if and when it gets here. Next slide, please. And then lastly, this is just a picture of our region office map or region map with region office contact information. And again, that 1-800 number for our veterinarian on call, or 24/7 veterinarian on call. In case you can't get with your veterinarian or have trouble reaching one of the region offices, certainly you can utilize that 800 number anytime, day or night, in any day of the week. So next slide, please. This is just some additional resources that will be included in this, and I believe that wraps up everything I've got. Thank you again, everybody, for your attendance today. Sorry it's running over a little bit, but certainly a lot of important information and great information has been shared. And we appreciate the opportunity to give you some updates today.
So yeah, we're going to conclude the webinar today. There are many websites that have been given from USDA, Texas State Health Services, Texas Department of Texas Animal Health Commission, Texas A&M AgriLife Extension, and probably a few others that I have forgotten. And I encourage you, there's a lot of good information. And of course, this webinar will be posted on our Screwworm website within Texas A&M AgriLife. We'll be letting the people that have registered know where that is. We'll be pointing you to that. And from that, I'm going to conclude. Please do the evaluation and help us do a better job next time and give us some good information as to whether this was helpful for you and how it could be more helpful for you. Hopefully talk to you again soon.